Hello. So right now we're going to graph this square root equation. Okay. We're going to be interested whenever we're graphing a square root equation. We're going to be interested in the domain, namely what are the possible x values that make sense to use with the equation. The range, what are the possible y values to choose with the equation. And we're going to be interested to know if there are any x-intercepts. There may or may not be. And if there are any y-intercepts. Again, there may or may not be. One of the interesting things about the square root equation is that for the first time, we have to really contend with the idea of calculating the domain. Because when we were looking at calculating, when we had lines, like let's say y equals 3x plus 4, or y equals 1/2 x minus 5, or anything like this, a line, we knew that the domain was negative infinity to infinity. Because that expression, let's say 1/2 x plus 4, can be evaluated with any choice of x. There's no restriction there. Similarly, if we had a quadratic, let's say we were calculating, let's say we were interested in y equals x squared plus 2x minus 3, that expression, x squared minus 2x plus 3, can be evaluated with any possible real number x. So the domain there was also negative infinity to infinity. But as you may now be aware, the square root is not defined, at least it's a real number, if the inside, the x plus 4, is negative. Okay? So that leads us to our criteria for finding the domain of the square root equation or square root function, depending on the perspective you're taking. And that is, we seek to find where the inside is greater than or equal to 0. Okay? So to find the domain of a square root graph, of a square root equation's graph, we find the x where the contents of the square root are positive. Namely, in our case, we're going to find the values of x that make this greater than or equal to 0. Are non-negative, positive or 0, okay? Because 0 is also, we can also take the square root of 0, okay? And so, and a little more generally, let's say that I was taking the square root of f of x, in other words, right? Where f of x is some expression in x, then this will be defined where the f of x is greater than or equal to 0. Okay? Okay, so for example, if we look at this, if I take x plus 4 greater than or equal to 0, so as long as this is satisfied, it'll make sense for us to take the square root. And in other words, it'll make sense for this to be it'll make sense for this to be evaluated. Okay, so now how do I solve this inequality? Well, I want to get the x by itself. We recall that solving an inequality like this is very similar to solving a linear equation. The only difference here is that if we were to need to divide or multiply by a negative on either if we were to need to multiply or divide by a negative, we would have to switch the orientation of the inequality. Okay, but that's not going to need to happen here. We'll see some examples later where that will happen. And so in this case, though, it's very simple. We just subtract 4 to the other side, and we see that x must be bigger than or equal to negative 4. Okay, now we're going to draw this on a number line really briefly so that it'll help us write the interval notation for this. First of all, this is x bigger than or greater than or equal to negative 4. So I put my negative 4 right here in the middle. And then, since it has the equal part, I'm going to put a filled in circle. And since the x is bigger than or equal to negative 4, I'm going to shade it to the right. Now, if I go to the right and I keep going forever, that means I'm getting closer and closer to positive infinity. So when I draw a number line, it helps me see the interval very clearly. Aha. First of all, I'm going to include my endpoint. So that'll be a square bracket, and it'll have a -4 there. I put my comma, and since I'm going toward negative infinity, it's going to go to negative infinity like that, okay? And it's going to be a closed parentheses because you can never actually get to infinity. And so the closed parenthesis says we don't include infinity. And of course, that's because we can't include it, right? Okay. So now, we also know something else. From these considerations, we know that we don't have to calculate, we don't have to make, if we were going to make, well, not if. Right now we're about to make a table to get an idea of the graph of this square root equation. So already here we have some insight about the graph. In our table, we already know that we don't have to plot any points to the left of -4. Why? Because the function is not defined there. It makes no sense to choose any point here because it will make the inside of the square root negative, and therefore it'll be a value of x that we cannot take the square root of. Okay? Okay. So now what we're going to do is we're going to make a table. Okay. And we're going to put our first point in here. It'll be the -4 because that's that'll the endpoint of our domain for the square root equation will always be the first point in our table. Yeah. So let's do that together. So now having realized what we realized, what we're about to think of right now is a good way of choosing those x points. Okay, those values of x which we're going to evaluate to get the points on our graph. So, but let's begin by evaluating the function at this point. So for x equals -4. I get, okay, y is equal to the square root of -4 plus 4. See, that -4 is the x, and then -3. But what is -4 plus 4? That's the square root of 0 minus 3. What is the square root of 0? The square root of 0 is 0 because 0 times 0 is 0. So that'll be 0 minus 3. And then what is 0 minus 3? That's just -3. Okay? Okay. So that goes here. Okay? Okay. Now let me also make something clear here. I know that sounded ridiculous for me to say the square root of 0 is 0 because 0 times 0 is 0. But I want you guys to remember that, for example, the square root of, like, let's say 81 is equal to 9. Why? Because 9 squared, or what is 9 squared? 9 times 9 is 81, okay? Okay, always keep this in mind. And notice how I verbalize it too. It helps to, when you verbalize these things, it helps to make you learn this better, right? So here, the square root of 81 is 9. Why? Because 9 squared is 81. In other words, what I'm reminding you guys here of is the fact that the square root is the opposite of squaring. So if we go 9 squared is 81, then the square root of 81 is 9. We're going backwards. Okay? If squaring, so in other words, if I take 9 and I square it, right? I get 81. Well, if I go square rooting, so if I take 9 and I square it, I get 81. And if I take 81 and I square root it, I go back to 9. Okay? Okay. So now we're in position to go further along in our construction of our table. Okay? Okay. Okay. So now, the thing I want to point out here, the important thing I want you guys to take away from this next part is how we use a little bit of insight and a little bit of thought to make our table. A lot of my students often ask me, David, what X do I pick, right? So let me be absolutely clear. In this case, we already know from our previous discussion that I'm going to pick X values that are to the right of -4. We already chose -4, of course, but we're going to choose points to the right of that, okay? But can I pick any point, right? That's the real question. And so let's say I were to pick X equals 1 as an example. If I take 1 here, 1 plus 4 is what? 1 plus 4 is 5. So I could have, so given what I just told you there, if I were to pick the value 1 as an example, I would have the square root of 5 minus 3. And although it is true that we can estimate this, okay, by hand, or we could use a calculator to get an approximation of this, this doesn't seem like the kind of number that's easy to plot on a number line. And I'm not saying that easiness to plot is a real consideration, but if you're going to draw a graph on paper, it would help if we had nice numbers. Aha! And I'm sure some of you have already figured this out. Aha! What was the problem with this? Problem with this is that the square root of 5 is not an integer. It's not a whole number, right? So, aha. I want to find those values of x that will make the inside of my square root perfect squares. Because if I make that happen, then I can make a table that's filled with just nice numbers, okay? And now again, I want to point out something else to you here. And I know that sometimes I might be a broken record when I say this, but it is true that some of these problems are like textbook type problems, and that sometimes these techniques of graphing may seem irrelevant and stuff, like to real life. But the reality is that, to draw these graphs on paper will develop intuition that you can later use when you're dealing with equations that are not so nice as textbook examples. Okay, so that's the value here. Okay. Anyway, so now having said all that rigmarole, okay, we're going to make this table. We're gonna continue this table. Okay, so for example, we saw that -4 made the inside of the square root 0. What's the next square after 0? Aha, 1. Why? Because the square root of 1 is 1, because 1 times 1 is 1. I know that one was kind of like bad, but I know you guys know that's true, right? 1 is our next perfect square. So how do we solve for that? Well, we just set the inside equal to 1. Okay, like this. Now I'm going to subtract 4, and I get x equals -3. Aha. So if I'm at -3, okay, and let me erase this point from our table because we're not going to graph it, okay? But I wanted to put it there when we were doing that discussion, just so you guys could see that with your own eyes, and so that you guys could know that why we're doing the way we're doing it over here, okay? But so yeah, so now we've gotten the x value of -3. We'll make the inside of this 1. So therefore, if I wanted to, I could just say, okay, y will therefore be, for this x value -3, y will be the square root of 1 minus 3, okay? Why did I get 1? Because that's what I set it equal to, okay? Or actually, let me just, for completeness, let me just go straight into that whole, let me continue doing it from beginning. So y equals the square root of, okay, -3 plus 4 minus 3. Now, -3 plus 4, aha, that's 1, right? which is exactly what it should be based on how we got this -3, right? We set the inside equal to 1, so we should expect that it should equal 1, and it does. And of course, we do know that the square root of 1 is 1, right? 1, and then we bring down the -3. And what is 1 minus 3? That's -2. Okay. So here it's -3, -2. Okay. What's the next perfect square? Well, I know that 0 squared is 0, 1 squared is 1. What's 2 squared? 4. Aha. So let me do that here. X plus 4. Notice I'm setting the inside equal to the perfect square. What is our perfect square now? 4. Minus 4, minus 4. And I get x equals 0. Right? So I can put that now on my table. That's going to be my next x value. Okay? And I'm now going to plug it in here. So y is equal to the square root of 0 plus 4 minus 3. Now, what is 0 plus 4? That's just 4. And then I bring down my minus 3. Now, what is the square root of 4? Well, as you already noticed from the way I got the 4, I had said 0 squared is 0, 1 squared is 1, 2 squared is 4. Aha! What's the square root of 4? It's 2. 2 minus 3. I brought down the minus 3 here. That's going to be -1. Okay? And then if I wanted to, I could do the next perfect square, which would be, I would say, okay, 2 squared was 4. What's 3 squared? 9. So I could do that, and let's do that, and that'll be our last point in our table, okay? Okay. So, x plus 4 equals 9. I'm going to get the x by itself by subtracting the 4, okay? So here it'll be x equals to 5. I'm going to plug that in here to get my corresponding y value. Y equals to the square root of 5 plus 4 minus 3. What is 5 plus 4? That's 9. So it'll be the square root of 9 minus 3. What is the square root of 9? It's 3. So I'm going to have 3 and then minus 3. That's 0. Aha! So my x there was 5 and my y value was 0. Okay? Now let me see here. Okay. So now we're in a position to, if we wanted to, we could graph this already. But I want to do a couple of things before we do that. Okay. So the first thing I want to point out for you is this. Actually, we already have the y-intercept. See? Since if x equals 0, we get the value -1. And we even already have at least one x-intercept, and that is the 5, 0, because if you notice the y equals 0 there. So if you recall, when you have a y equals 0, the x value is the x-intercept, okay? Or is one of the x-intercepts. We will find out, or not we will find out, but the square root will only have one x-intercept and one y-intercept, okay? If it has an x-intercept, it'll only have one. If it has a y-intercept, it'll only have one, okay? Now, I'm talking about square roots of linear functions like this, where it's just like the square root of ax plus b for some constants a and b, okay? If the inside of the square root is more complicated, it can intersect the x-axis multiple times, and if it might also have other properties. There can be other cases like that. We're going to see that a lot later, but for our discussion for these examples for this example and the examples that follow within this section, it'll only have one x-intercept and one y-intercept. But let's go through the procedure to verify that, and to find out how it would be done if we didn't need to know any of this. Okay, if we had not found them here, let's see how we would find them out. And yes. So if you recall, whenever we want to find the x-intercepts of a function, we're going to set the y equal to 0 and we're going to solve for x. So the reason why we're going to do this is that we want to verify, for example, let's say we didn't know what we had just discussed. Let's say we didn't know this x-intercept, or let's say we wanted to find out, is that the only one? Because of course this is an important question. So what we would do is we would set the y equal to 0. So I'm going to take this expression, which equals to y, and I'm going to set it equal to 0. So the square root of x plus 4 minus 3, that equals to 0. Okay? At least in the case of the x which correspond to the x-intercepts. Okay? How do I solve this equation? My goal when I'm solving a square root equation is I'm going to first isolate the square root term. In this case, the only thing I have to do to do that is I have to add 3 to the other side. Okay? Okay. So that'll be the square root of x plus 4, okay, equals positive 3. Okay? So now, now, if we look at it right here, we've got the square root term by itself. So we're in business. Now we need to get rid of the square root term. So what are we going to do? We're going to square both sides, okay? So if I do that, then I'm going to get the square root of x plus 4 squared equals 3 squared. Now when I square this, it's going to take away the house. So I'm going to have x plus 4, okay? In other words, when I square the square root of x plus 4, the square root house gets removed. And what is 3 squared? That's just 9. So you see, aha, I subtract 4, and I get x equals to 5. We can see that's exactly the x value that's here on our table that corresponds to this x-intercept, which we saw was an x-intercept because the y was 0. And so, but the valuable information that we gained from performing this algebraic calculation is that there is no other x-intercept. There's only one solution to that equation. Okay? And now we're going to see about the y-intercept. So here, to find the y-intercepts of a function, we set the x equal to 0 and solve for y. Well, strictly speaking here, we would say the y-intercept, okay? If it's a function, it'll only have one y-intercept, because if it had more than one y-intercept, it would violate the vertical line test, which we use for testing for functions. And so there, to find the y-intercept, we set the x equal to 0 and solve for y. Okay? So let's do that together now. Okay? I'm going to take my y equals, I'm going to set my x equal to 0, and then I'm going to see what the corresponding y value is. Well, we know that 0 plus 4 is 4, so this will be the square root of 4. I bring down my minus 3. What is my square root of 4? My square root of 4 is 2. Okay. Okay. Why? Because 2 times 2 is 4. And then I bring down my minus 3, right? 2 minus 3 is negative 1. Okay. And I can see that that is exactly this point that was already in our table. So again, as before, even though this seems superfluous, the advantage of having done this is I know that I got the only y-intercept. Okay, there is no other y-intercepts. Okay, okay, okay. So let's list that in our table explicitly. Our x-intercept we saw was 5, 0. Our y-intercept was 0, negative 1. Of course, those were already in our table, but I want to list them explicitly here in our table of information that we're interested in. Now I'm going to draw the graph, and at the end, we're going to identify the range. Okay. So now, whenever we're drawing a graph, you want to look at your table to see more or less where on the graph paper you want to focus. I know if I want to draw this whole graph, I need to have x equals 5, and I need to go all the way to x equals negative 4. The y's, though, I don't need any negative value. Well, no, I'm sorry. I need no positive values. So in other words, if I wanted to, and of course I'm going to do it that way because I can, because, you know, I just choose to. I'm being kind of, I'm joking there, of course. But I'm going to draw it like this because I'm going to focus on where the graph is. So here, let's say, I'm draw this right in the middle, more or less, right? I don't need positive values of y, at least for this part of the graph, right? Yeah. And so that's why I'm focusing mostly on quadrants 3 and 4. Okay, 1, 2, 3, 4, 5. That's my x value 5. And then 1, 2, 3, 4, negative 4, negative 3. And then here, 1, 2, 3. Right? Now I labeled my x points above the x-axis because I know my graph is going to be on here, so that'll help me to prevent it from looking very cluttered. So negative 3, negative 2, negative 1. In other words, what I want you guys to realize is that whenever I'm drawing the graph 2, I'm making an effort not only to just draw the part of the graph paper that's important to the problem, right, by looking at the table of values we've chosen, but also I try and figure out where to put my numbers so that it'll maximize the readability of my graph. Here, negative 4, negative 3. So I'm going to go negative 4 along my x, and then negative 3 on my y. So it looks like about right there. Negative 3, negative 2 again. I'm going to go to the left along my along my x for my negative 3, and then I'm going to go 2 down, like right there. Okay, that's perfect. And then 0, negative 1. So that's going to be right here, right? That's this point here. And then 5, 0. So that's right there, okay? So let's relabel that. Here, so it won't interfere with our graph. And what you can see is that this will have. I'm going to try and join these with a smooth curve, okay? Like that, and it's going to go like that forever. And oh my God, that is. I swear, I'm always in a competition with myself of drawing the ugliest graph that ever existed. I mean, it's amazing. Okay, I put so much effort in, it looks like it's just a straight line there. It's not the way it's supposed to. But what I want you guys to observe, in all seriousness though, is that my y values are going to go from negative 3 to positive infinity because the graph is increasing. Okay, so that's going to be negative 3, comma, infinity. And now, as I mentioned in the introductory video, there's only 4 situations. Either the square root is going to look like this, the square root is going to look like this, the square root is going to look like this, or the square root is going to look like this. Given this situation, we know it's like this, okay? And so we do know that the y will go from this value to infinity, okay? And we're going to see the other cases as we go along. But so this actually is completely consistent with what we discussed, okay? And let me see here. Is there anything else I want to tell you about this? Okay. That is all for this that is all for the graph of this equation, and I look forward to seeing you again soon. Thank you.